Morning students, welcome to mathematics class. Today we are going to start our first chapter, that is relation and function. So today I am going to teach you about function. So what is a function? We can define a function as a special relation which maps each element of set A with one and only one element of set B. Therefore, every relation need not to be a function, but every function is a relation. So, in other words, we can say that a function f from a non-empty set A to a non-empty set B, such that every element of set A has one and only one image in set B under F. Therefore, A to B is a function such that for A belongs to A, there is a unique element B belongs to B, such that AB belongs to F. So here comes the function notation. When a function f is defined with a rule or an equation using x and y for the independent and dependent variables, we say y is a function of x to emphasize that y depends on x. We use the notation y equals to f of x, called function notation, to express this and read fx as f of x. The letter f stands for function. For example, if y equals to fx 5x minus 2, we can name this function f and write f of x equals to 5x minus 2. Note that fx is just another name for dependent variable y, and also the symbol fx does not indicate f times x but represent y value for the indicated x value. As shown below, f3 is the y value that correspond to the x value 3. Therefore, y equals to fx equals to 5x minus 2. So, y equals to f3 equals to 5 of 3 minus 2 equals to 30. There are some examples using function notation. Example 1. Let fx equals to x square plus 2x minus 1. So find f4. So here is the solution. Fx equals to x square plus 2x minus 1. So if we replace x with 4, so f of 4 equals to 4 square plus 2 of 4 minus 1. So f4 equals to 16 plus 8 minus 1, that is f4 equals to 23. Since f4 equals to 23, the ordered pair 4, 23 belongs to f. Example 2. Let gx equals to 5x plus 6. Find and simplify g of n plus 2. So here is the solution of example 2. Gx equals to 5x plus 6. So if we replace x with n plus 2, therefore g n plus 2 equals to 5 of n plus 2 plus 6. equals to 5n plus 10 plus 6 equals to 5n plus 16. Example 3. For each function, find f7. We want f7, the y value of the ordered pair where x equals to 7 as indicated by the ordered pair 7, 15, where x equal to 7, y equals to 15, so f7 equals to 15. Now example 4. For each function, find f7. See the figure. So the domain element 7 is paired with 17 in the range. So f of 7 equals to 17. Now comes to example 5. For each function, find 7. With the help of figure, to evaluate f7, find 7 on the x-axis, then move up until graph of f is reached moving horizontally to the y-axis, gives 3 for the corresponding y value. Thus, f7 equals to 3. Now comes the type of function. So in our syllabus, there are 3 types of functions. These are one-to-one function, on-to function, bijective function. So here comes to one-to-one function. It is a function where f such that a to b is said to be one-to-one function if no two distinct elements of A have same image in set B. For example, A equals to A1, A2, A3, A4 and set B equals to B1, B2, B3, B4 and see the figure. Now comes the onto function. If there exists a function for which every element of set B, there is pre-image in set A, it is onto function. Onto is also referred as surjective function. For an example, A1, A2, A3, A4 and set B equals to B1, B2, B3, B4. And see the figure. Now comes the bijective function. It is a function where f such that a to b is said to be bijective if it is both one and onto function. In other words, the function is associate each element of A with a distinct element of B and every element of B has a pre-image in A. That is f equals to 10, 15, 20, 45, 30, 25, 40, 35 as ordered pairs. Set A equals to 10, 20, 30, 40 and the element of set B equals to 15, 25, 35, 45 and see the figure. Now comes composition of function. Function composition is an operation that takes two functions f and g and produces a function h such that h of x equals to g of f of x In this operation, the function g is applied to the result of applying the function f to x. That is, the function f such that a to b and function g such that b to c are composed to yield a function that maps x in a to g of f of x in c. And see the figure. Now comes inverse of function. An inverse of function will undo every action on the variable. Consider what is being done to the variable along with the order. To find the inverse, reverse the order and the action taken on the variable. Example, of f of x equals to 2x minus 4 by 3. To algebraically solve for the inverse of a function, switch the domain and the range, switch x and y and solve for y. Consider what being done when applying this method compared to logical method. Inverse of function FOG, that is gx equals to 3x plus 4 by 2. Now that switching the domain and the range of function will give the inverse. Now comes inverse of function. Verifying inverse of function. As we earlier did FOG equals to f of g of x. Now we go for GOF equals to g of f of x. FOG equals to GOF equals to x. If f of x equals to 2x minus 4 by 3 is a function and gx equal to 3x plus 4 by 2 is inverse of function, then f of g of x equals to g of fx. So now comes the homework for you. Do question number 2, 5, 7, 10 of exercise 1.2 of NCERT and question 2, 5, 8 and 10 from exercise 1.3 of NCERT. Thank you.